last lecture we talked about mass percent and how to find mass percent and what it is. And so now we're going to say, okay, we don't necessarily want to find mass percent, but what if they give me the mass percent? How can I use that as a conversion factor? So if they give you the mass percent, I want you to kind of think about what that means. So I want you to think about the fact that the mass percent tells you the mass of a constituent or specific element. And we're going to say, because it's a percentage, in 100 grams of the compound. So, for example, in CCl2F2, it is 58.64% chlorine. Okay? So what I want you to do is when you see that I give you a percent, a mass percent for a specific element, then I want you to be able to kind of rewrite this. I want you to rewrite this as 58.64 grams of chlorine in 100 grams of the compound. We're taking the percent and we're changing it from a percent to a ratio. Okay? So I'm going to change it. I know it's this percentage over 100. So if I say it's this many grams and 100 grams, if you do the math, you actually can go this divided by this times 100 gives you this percentage. So whatever the percentage is, whatever that number is, we're going to say it's that many grams, and it's always going to be 100 grams of the compound. Now, the reason we want to do this is because we want to be able to convert from the part to the whole, or to go from the whole to the part. This is the first time we're going to be able to go from one thing to something completely different. So, for example, say I had the grams of my whole thing. Some number of grams. I can actually use my mass percent to go from grams of this whole thing to grams of just the part. I could go from grams of the whole to grams of the part using this mass percent, because the whole is 100 grams and the part is whatever that percentage was. And that would give me the number of grams of just the carbon. So I could go from the whole to the part, but I can also go the opposite way. So if I had grams of carbon, I could go the opposite way. I could go from grams of carbon, my part, to my whole. If I'm talking about the part, then the percent is what goes here. If I'm talking about the whole, then 100 goes there. So the bottom would be the 58.64 and the top would be 100. When I do that math, I would get the number of grams of the whole thing. So this is going to be really helpful because now I could go from one thing to something completely different. But there is one caveat. These two things have to be related, meaning that the part has to be part of the whole. So that element has to be included in here. So I can't go from CCl2F2 to like hydrogen. Okay? I can only go from a whole compound to an element within that compound, and from an element within that compound to the whole compound. Okay? So that's the only way that I can go from one to the other. Alright, so let's do a problem. So this says find the mass of table salt containing 2.4 grams of Na if there is 39% Na in table salt. Alright, so what are we looking for? We want the mass of table salt. I don't have to know what the formula of table salt is. I just write down table salt. And when I say I want the mass of table salt, I want that in grams for this problem. I'll always tell you, what did they give me in this problem? So they said I have 2.4 grams of Na. And they told me that there's not 39% Na in table salt. So they gave me a percentage. Okay? So one of the things that I want you to automatically think of is they're saying 39% of Na, an element in a compound. Promise I don't have COVID. My throat is dry, I need to get some water. All right. So what this is saying is this is the percentage of the element in the compound. So what I want you to do is I want you to rewrite this. So I want you to rewrite this as 39 grams of the element in 100 grams of your table salt. Yet again, you don't have to know what table salt is. Okay? You just have to know that sodium is in it. And it tells you that in the problem. So I changed my percent to be whatever the percentage is, it's that many grams of the element, and it's always going to be 100 grams of the compound. So the element within the compound. So then we want to say, well, where do I start? Okay, so do I want to start with the 2.4 or do I want to start with this percentage that we rewrote? This is complicated, and remember, we're going to use percents as conversions. So if you see the percent, you don't want to start there. You want to start with the 2.4 grams of sodium. I have sodium, I'm trying to get to table salt. I'm trying to go from one thing to something completely different. The only way you've learned to do this so far is using the percent, but that assumes that this is in that, which we know. We know that sodium is in table salt. So the way we set this up is we want the grams of sodium to go away, so it goes on the bottom. I'm trying to get to grams of my table salt. Okay? So I'm trying to get rid of sodium, so it goes on the bottom, and I'm trying to go to table salt. So now it's really important to write your units and what they are for. Grams of what? Sodium. Grams of what? Table salt. So then I need to know what relates the element to the table salt, the part to the whole. The percent does. The 39, it's 39%, 39 grams of Na. So the 39 has to go with grams of Na. So 39 goes on the bottom. And I have 100 grams of table salt, so that goes on top. Grams of Na cancel. I do the math, and I get 6.2 grams of table salt. And that's it. I didn't have to know what table salt was. I just have to be able to set up this relationship. All right, let's do another one. Benzaldehyde is 79.2% carbon. What mass of benzaldehyde contains 19.8 grams of carbon? So what am I looking for? I'm looking for the mass of my benzaldehyde. I'm just going to shorten it of that. And to let you know, I want it in grams. What did they give me? They said there's 79.2% carbon in benzaldehyde. So benzaldehyde is this much percentage of carbon. So 79.2% of carbon is in benzaldehyde. And they gave me 19.8 grams of carbon. So like always, I want to change this percent. So I want to change the percent to grams. And it's that many grams, the percent is always for that element. It's going to be in always 100 grams of whatever the compound is. I don't have to know what the compound was. In the last example, I didn't have to know what table salt was. I just had to know it was the compound. Okay, so benzaldehyde's the whole. Carbon is part of it. All right, so where do I start? I don't want to start with the percentage because that's a lot of words and that's confusing. So let's start here. I have 19.8 grams of carbon. I don't want carbon. So grams of carbon goes on the bottom. What I want is the mass of benzaldehyde. I want the grams of benzaldehyde, so I put that on top. So now I want something that relates the part to the whole. I know carbon is in benzaldehyde, so I need something that can go from one thing to something else if they're related. If this is a part of that, and that's the percent. So what do I need? So what is going to go with the compound? The compound is always 100%. It's 100 grams. The number that goes in front of the element is whatever the percentage was. The percentage was 79.2. We changed it to grams, so that's what goes with the element. Grams of carbon cancel. I'm getting 25 grams of benzaldehyde. Didn't have to know what it was, but just understanding the percent relationship, the mass percent relationship of the part to the whole, I could go from one thing to something completely different. Okay, that's the first time we were able to do that. On the next lecture, I'm going to tell you one other way that we can go from the part to the whole or vice versa, but instead of using mass percent, we're actually going to use the formula to figure that one out.